Lesson 12.1b, Calculating Trig Ratios. Now, in the last lesson, we just got done talking about important conclusions with similar triangles. If we have a right triangle and a second specified angle, then first of all, we can conclude that that triangle is similar to every other right triangle with a second angle of the same measure. And more importantly, every other right triangle with the same second angle must have the same proportions with its sides as this given triangle. So, for example here, here's a quick review from yesterday's lesson. Given these two triangles, you can clearly see that these two triangles must be similar because all the sides are proportional. The same scale factor between the smaller legs to the larger legs are all the same. 3 to 6, 4 to 8, 5 to 10, it all reduces to 0.5. So, therefore, the triangles must be similar because of the SSS similarity conjecture. And then, what is the sine ratio of angle A? Well, angle A below, the side opposite it is 3. The hypotenuse is 5, so the sine ratio has to be 3 over 5. Now, there's one more important conclusion here, and that is this. Since two similar triangles will always have the same proportions, they will therefore always have the same trigonometric ratios. Now, what those ratios are, we don't quite know that yet, but that doesn't matter. What's important is that the ratios will always be the same. No matter what value they are, the ratios will always be the same. So to calculate trigonometric ratios, let's say in these two triangles here, we have in the two triangles, we have a 35-degree angle and a 90-degree angle. So since both triangles have the same two pairs of angles, then they are similar by the A similarity conjecture. Now, since we just got done concluding that the trigonometric ratios will be the same, that begs the question, what are the ratios? Because as you can see in those two triangles, there's no side lengths given. So how can we figure out what the sine, cosine, or tangent ratios are if there aren't any side lengths given? Doesn't matter. The ratios exist, and they have to be the same no matter which triangle. Well, the easiest way to figure out the actual ratios then is to use a calculator. You'll notice on every calculator, at least on every scientific calculator, there's these three buttons, the sine, cosine, and tangent buttons, abbreviated SIN, COS, and TIN. Now, if we use these buttons, we could take the 35-degree angle, type in 35 and hit the sine ratio, and it'll tell us that the sine ratio of a 35-degree angle is 0.5736. And that's consistent. No matter how big or how small the triangle gets, the sine ratio of 35 degrees will always be 0.5736. Also, we can do the same calculations with the calculator for the cosine and tangent ratios. Type in cosine of 35 degrees in your calculator, you'll get a ratio of 0.8192, or tangent of 35 degrees, you'll get a ratio of 0.7002. We strongly recommend that you use 4 decimal digits for your trigonometric ratios. That will give you the precision you need for all the math that we're doing in this unit. Now, if you'd like, if you prefer, you can do it the way we did before calculators came along. And that was we got these giant thick books listing every trigonometric ratio. But unless you like lugging around a 10-pound reference manual that's about 200 or 300 pages thick, I suggest you just go out and get yourself a cheap scientific calculator. Now, let's say we wanted to do a little more trigonometric measurements, except this time we don't know what the angles are. We know all the side lengths. Say, for example, in this triangle here, triangle ABC, we have side lengths of 6, 8, and 10. Let's say we wanted to know what the sine ratio of angle A was. Well, that's pretty clear. We know what the opposite length is. That's 6. We know the hypotenuse is 10, so the ratio has to be 6 to 10. But then what's the actual measurement of angle A? Well, guess what? Your calculator can do this too. Now, on your calculator, not only do we have these sine, cosine, and tangent keys, there's also the inverse sine, cosine, and tangent keys. So if you do 6 divided by 10 in your calculator, and then do the inverse sine of that ratio, you'll get an angle measure of 36.87 degrees. Also, just note that the notate for the inverse sine ratio is written as sine and then a superscript of -1. Don't worry about why we're using -1. That notation means the inverse sine ratio. So instead of actually typing in the angle measurement into your calculator and getting a ratio, you type in the ratio and you get an angle measurement. That's what the inverse sine button does. Thus concludes today's lesson.